My dear friends, today I will discuss with you the working of the half header and the working of the full header. Okay. Now what we mean by, first of all, the half header. Half header, basically it is a combinational circuit that performs the addition of the two bits. This circuit needs two binary inputs and two binary outputs. So now what's about the truth table? Now here is inputs x and y, 0, 0, 0, 1, 1, 0 and 1, 1. Now let me take the sum. 0, 0, sum 0, 0, 1, it is 1, 1, 0, it is 1. What about 1, 1? The sum is 0 and carry 1. Now here for three combinations there is no carry. The carry is only when you sum 1 and 1. That becomes the sum 0 and carry 1. So this is all about the truth table. Now coming to the Boolean equations. You know how we write the S using this truth table? You just see where is 1. 1 is at here. So this 1 is what? What are the inputs for this one? This is 0. 0 means x complement. And then y is 1. That means only y. So first min term is x complement y. Now second min term is where is the second in the sum? Here. And what about the inputs? Here x is 1. That means only x. This x. But you know for this one y is 0. That means y complement. And you put it here a plus sign because the main terms sum of the product form. Now let's coming for the carry. So carry there is 0, 0, 0. Only 1 is here. And only one term. What about x is 1 and y is 1? So xy only, main term. So this is the carry. So if you use the exclusive OR gate, then x complement y or y complement x is nothing but the exclusive OR operation. So S is equals to x exclusive y, whereas carry is only xy. Okay, now let me study about how we make a circuit for sum and carry. You know, for sum we need x complement y and xy complement. So here this line, this whole line, this is x. And then here is a NOT gate. With NOT gate, the whole line becomes x complement. Now this is a y line, and then here's a NOT gate. The whole line becomes y complement. So just see, we are taking a connection from x. So this is x, and one connection from here, from y complement. So this is an AND. What becomes here? Here becomes x, y complement. Now coming to this AND gate, one connection is here. So one connection is here mean this is y complement. One connection is here. So this is what? X complement. So x complement. Then second connection is here. What is this line? What is this line? This line is y line. So this is x complement y. Now here is a OR gate. For OR gate, the S becomes this is OR gate, the sum becomes. For OR gate, the S becomes, sum becomes. The sum becomes this plus this. Okay. That means this equation. Right. Now we're coming to the carry. One connection is taken from here. This is X line. One connection is taken from here. This is Y line. So AND gate mean carry is XY, the second equation. Now coming using the exclusive OR gate. X line, Y line. This is exclusive OR gate. Here S becomes directly X exclusive Y. And then X line, Y line, AND gate. C becomes XY. Now coming to the, for full adder. Now coming to the full adder, Boolean equation. For full adder, we are having the three columns, X, Y, and C in. C in means the carry from the previous state. Okay, carry from the previous state also becomes the input for the new addition. So this is carry from the previous. Okay, so this also becomes the input. Now taking the different combination of X, Y, and C in. How? For X, 4 zeros and 4 1. For Y, 2 zeros, 2 1, 2 zeros, 2 1. And let we define C input. Let's say, not necessarily, let's say it is 0 1 0 1 and like that. So we are having the different combination for the three inputs X, Y, and C in. Now taking the sum. Okay, so for all the three zeros, the sum is 0. Out the carry last, now the carry bit which becomes 0 also. So this, the 3 is the 0, 0 and 1. The sum is 1, carry 0. 0, 1, 0, the sum is 1, carry 0. 0, 1, 1, the sum becomes 0, but the carry 1. 1, 0, 0, the sum becomes 1, carry 0. 1, 0, 1, the sum becomes 0, carry 1. 1, 1, okay, the 1, 1, the sum becomes 0, carry 1. 1, 1, 1, the sum becomes 1 and carry also becomes 1. Now coming the sum S. Now for the S, you just see where is 1. 1 is here. So what is this? X complement, Y complement, and C in. So first term. Now 1 is here. What is this? X complement, Y, and C in complement. Second. Now 1 is here. X, okay, X, Y complement, C in complement. This one. Last. 1, 1, 1. So X, Y, C in. This one. So C in complement common. C in is here. C in complement is here. Okay. C in complement is here. So taking it as common. So what left? X complement Y plus XY complement. Now C in is here. C in is here. So C in is common. X complement Y complement plus XY. Okay. Now then next, what is this becomes C in. This can be written as X complement Y plus XY complement, then whole complement. If you open it using De Morgan's theorem or simplify the expression otherwise without De Morgan's, then you'll get this expression. So this expression can be written as X complement Y plus XY complement, then whole complement. Now what the relation is now? Here there's this function then C in complement, then this function complement, and C in without complement. So this is nothing but the exclusive operation between this and with this. But basically this function is again the exclusive functions, exclusion between x and y. So ultimately there's an exclusion between all the three inputs: C in exclusion, x exclusion, and y. Okay, so this is our final result. Unless you are understanding, because this C in complement, then a function, then C in without complement, then function complement. This function is what? Exclusion between x and y. Now the exclusion, or the whole becomes exclusion between C in x and y. So this is the sum. Now we come into the carry. You know what is carries here? You know the carry is here. What is this is x complement, then y and C in. Then 1 is here. This becomes x y complement, x y complement, C in. 1 is here, x y C in complement. 1 is here. This becomes x y and C in, and taking sum of all the min terms, that becomes the carry. So the carry output becomes, this is just a small exercise for you. First of all, writing all the min terms for this one, for this one, for this one, for this one, and simplifying it, minimizing the expression, you will ultimately get this Boolean expression. Very simple. I left it as an exercise for you. So it becomes C in, then x exclusion y plus xy. This is x line, this is y line, this is C in line. Okay. First of all, this is exclusive OR gate. So what it becomes, and the connection is here and here. So x exclusive y, right? Now this is again, the input is here, one input from C in. Now this is C in, this is x exclusive y. So both the becomes the input. X exclusive y and C in, both are the inputs here, and again exclusive OR gate. What the result becomes? X exclusive y exclusive C in, which is the sum. Now coming to the carry. So first of all, this is the AND gate, and two inputs are x and y. So here becomes x y. Okay, x y. Now this line is coming, x y is here, and one AND gate is here. This AND gate is, one connection is taken from this point. This point is what? X exclusive y. And just see where is the second one. Second one is coming from C in. So this is C in, this is x exclusive y. What becomes here? It becomes, it becomes C in bracket, was second input, x exclusive y. So here becomes x, then exclusive y bracket. Now this output is here, and one output is coming from here, XY. Then there's an OR gate. What becomes final? Final is this C in bracket X exclusive Y, okay, and C in plus the second which is coming, this XY is coming, XY line, the OR operation, that means the plus. So this is the last carry out, okay. So this is circuit for C out and the sum of the full adder.